Alright, this is still test your review, and this is problems 22 through 25. And we are multiplying and then writing the answer in those terms. So these are multiplying fractions, basically. Alright, and for the first one, number 22, it's 1/5 times 1/2. The good thing about multiplying fractions is that you just multiply the numerators, then multiply the denominators to make the new fraction. So 1 times 1 is 1. 5 times 2 is 10. So if the answer to 22 is 1/10. Number 23, 1 times 13. But I'm trying to think of a faster way to do this one. 13 plus 13 is 26, so 13 times 2, so I can't reduce this more. That's what I was thinking maybe I could do. But I think 29 is a prime number, and so is 13. So we just have to go ahead and multiply 13 times 1, and then 6 times 29. Well, you don't know 29 times 6 off the top of your head, so you just kind of have to do it off on the side here. And this is what you'll have to do on the test because there are no calculators. Wow, that's a big number, 13 over 174. Now to see if that's reduced, we have a prime number here. If 13 does not go into 174 evenly, then this is already reduced. So let's look at that. Let's see, does 13, we'll do it on the side here, go into 174? Let's answer the question. And that would be 52. So we can't, that is already reduced. So that's the answer here. Let's circle our answers in red. Okay, and I'm going to clear my scrap. So number 24. Now, multiplying 12 times 40 times 15 is the process, but we can do what's called cross-canceling. And you can only do this with multiplication. So we should write that down on the side. I'm going to use this a different color for the cross-canceling. So cross-cancellation means you're finding numbers divisible by both one of the numerators and one of the denominators. It can be any one of the numerators or any one of the denominators. So I know that 15 and 25 both are divisible by 5. So let's divide these. 15 divided by 5 is 3. So we'll say divided by 5 is 3. Ooh, that's complicated, huh? So then, that's what I did. 15 divided by 5 is 3. So we've just changed the 15 to a 3. Now, 5, we have to divide this one. We divided this one by 5, so we have to choose a denominator to also divide by 5. So I'm going to divide this one by 5, and I get 5. 25 divided by 5 equals 5. And this is messy. Divided by 5 equals 3. So that's changed to a 3, that's changed to a 5. Okay, so now you can continue to look for other things. 5 and 40 are also divisible. But I want to use a larger number. I see that 8 times 5 is 40, 8 times 4 is 32. So I'm going to cancel on the 40 and the 32. So I'll divide this one by 8 to get 5. I'll divide this one by 8 to get 4. So here I divided by 8, 32. This one is 40. This can get messy. Now I've got 5 over 5, so I'm going to do a second cross cancellation. Cross out the 5 and that 5, and they each turn into 1. I've got a 3/4 here, I've got a 1, I've got a 1. We're making it much easier. I see that 6 goes into 12 and 6 goes into 66. So let's reduce that. Let's So but we use a different color. So 6 into 12 is 2. 6 into 66 is 11. So now we have this 2, 1, and 3, 1, 11, and 4. That makes things much easier. Let's do our equal sign. Now we can multiply because we essentially reduced fractions. That's what we really did. And it's called cross-canceling because you're doing it, you're going over this fraction line, but you're going across this way, or you can look at it even as far as that way. And we now have 2 times 1 times 3, and that's 6. And we have 1 times 11 times 4, that's 44. Well, we can still go down one more time. Oh, and I missed that. I could have reduced again, 2 and 4. But I can do it this way. I can divide both of these by 2, and I will get 3 divided by 2, 20 seconds, and that's my final answer. So on this one, I'll show you how that works. If you were to rewrite this problem, because you can rewrite it, one long fraction line, and you have 48. Well, the reason I can reduce or cross cancel, as it were, is because these are all numerators over all these denominators. And because of the commutative property of multiplication, you can put the numbers on the top in any order you want. And you can put the numbers on the bottom in any order you want. 27 is the same. 27 times 24 is the same thing as 24 times 27. You could put 24 here in the front and have 24 times 64 times 27. Because those can be rearranged, that's why you can look at 48 and 24 and decide to cross cancel. 12 goes into 48 4 times. 12 goes into 24 2 times. Well, I can keep going with my reducing on that problem, and we'll just choose other colors. 2 into 4 is 2. 2 into 2 is 1. Now we can look at 45 and 27. 3 goes into 45 15 times. 3 goes into 27 9 times. And I could still go one more time. 3 goes into 15 5 times. 3 goes into 9. 3 times, so what did I do? Oh, I could have gone 9 into 45. That's right. 9 into 45 is 5, and 9 into 27 is 3. Okay. Well, no matter how you get there, it still works. Okay, so if we were to take, let's use another color, 16, I think, goes into 64. Yes. Okay. So 16 goes once, 16 goes into 64 4 times. And now when I multiply, I'm multiplying, let's write it again. The 2 times 1 times 5. 4 times 3 times 1. I have reduced fractions all over the place until I'm making this multiplication much easier. And what I can do is one more cross cancellation. 2 into 2 is 1, 2 into 4 is 2. So now I have 5 6 as an answer. And I wrote it in red, so I'll have to circle it in black. 5 6. So cross-canceling works because of the commutative property of multiplication. And yeah, you have to know your multiplication tables pretty well, but it's a very useful tool, and it keeps you from having to multiply these huge numbers.